Okay, so so I need you guys to just put your names in the chat just so I have an idea of who's here in this session or not. So today we're going to be talking about eh, about hooks, more advanced hooks in React. And so today we're going to be covering advanced
Mm,
hooks, React optimization, and API based sort and search. And
yeah,
then we
something good.
Like what?
Okay, so this is going to be the agenda for today's session, where we're just going to be talking about why optimization matters, and then some advanced hooks with useMemo, useCallback, and React.memo, and then we'll just take some look at data operations, comparing local logic versus API-based sort and search, and then we will just take a high level look at some uh, best practices for API that involves caching, throttling, and pagination. So let's try and start us off with why do we even need to optimize our the uh, let's just take a look at why optimization matters in the first place. So by default, React is fast, and it would still re-render certain components whenever the state or properties changes. But when it comes to larger apps, that all that work starts to add up, which ends up being very unnecessary. So the two problems that usually occurs in apps like these are expensive calculations, which tend to run on every render, and some unstable function references, which cause child components to re-render, even when they don't need to. So the golden rule here to take away is that don't optimize blindly. I would always recommend measuring first with the reactive tools profiler, and then you could try to identify actual bottlenecks before making any changes. And then let's take a look at some and this is where use memo comes in. So the idea behind use memo is very simple. It caches the result of an expensive calculation so that React does not have to recompute or it on every render. So in the example on the right here, we are just memorizing the filtered list so that React only reruns that filter when its dependencies, items, and query actually change. So a good way to think about it, it's like saving the answer to a hard math problem uh, so that you don't have to solve it again and again. So if the inputs stay the same, you can just reuse the same answer. And then how does it work? It usually stores the result of a function, and then the dependency array tells React to recalculate only when these specific values change. Now let's take a look at use callback. While the use memo caches a calculated value, use callback caches the function definition itself, so that React can keep the same function reference between renders. So the reason that particular thing matters is that in React, every time a parent component re-renders, it normally creates a brand new function. So even if the logic is the same, the reference is still different, and that can cause child components to re-render unnecessarily. So the core purpose of use callback is just to stabilize function references between renders. A more simpler way to explain it would be instead of handling the child component a brand new function every time, you're giving it the same one unless its dependencies actually change. So in this example on the right, you can see that the add to cart function is wrapped in use callback, and because its dependency array is empty, React creates that function once and it keeps reusing it. So this is especially useful for when you are passing callbacks down to child components that have been memoized because then React.memo can actually prevent those unnecessary re-renders. And then let's take a closer look at uh, when do when do you want to use memo, and when do you want to use callback? So use memo, as we discussed earlier, it caches a value while use callback caches a function. And then use memo gives you the result of a function, and it is typically best for expensive calculations, filtering large arrays, and the and also if you're trying to keep a function property stable between renders, use callback is more useful, and it also returns the function itself. So the rule of thumb I like to use to differentiate between these two hooks is that use memo is for the output of doing something, and use callback is for the thing that does it. And this leads us directly into React.memo. It is what helps us prevent the child component from re-rendering when its properties have not changed. Uh, but that also only works if the properties, especially the functional props, they stay stable. This is why it has been observed that React.memo and use callback are so often used together. So so some of the key features of this particular of React.memo would be that it's a higher order component, which just means that it wraps a functional component and it memoizes it. And second, it performs a shallow comparison of old properties versus the new ones. And then the third point is kind of like a big one. It works best when function properties are stable, which is why it is so commonly paired with use fallback. So React.memo helps React skip the re-rendering part of child components when the properties have not changed. But if you keep passing a brand new function on every parent render, then React sees that as a change prop. So even if you use React.memo, it will not help that much. And then this example, the button would only re-render if certain properties change, and this is kind of one example as to how this particular hook can be used. And now let's take a closer look at and now let's try to take a closer look at where your logic should actually live. So there are only two places that it could live. Maybe it could be in the front end or through the API itself. So, there is no answer that would be like universally right. There's always a choice to be made, and it depends upon the scale of the app and performance needs. So, you also have to consider the data set or the amount of data records that you're dealing with. If it is small, usually under a few hundred items, then local filtering and sorting is often the simplest choice. It feels instant, there's no network delay, and it is very easy to implement. But as your data set gets larger or your queries start to become a bit more complex, API-based sorting and searching starts to become more sense. The server can handle large volumes of data, and they can help you return what you need and keep the results fresher. So, if the data set is smaller, you can always start with the local based logic, and then if the app grows in size or complexity, that is where you could try to move towards API based operations. And then let's try to take a look at some of the practices that can be possible. And one of those practices is caching. So the core idea behind this concept is really simple. If the user searches for the same term again, you don't want to make the same exact API call twice. Instead, what you can do is you could store previous results and reuse them. So the flow behind this process would be that the user searches for something. The app first would check whether that term already exists in the cache, and if it does not, and if it does, it serves the cached result immediately. And then if it does not, it can fetch from the API, store that response in the cache, and then it saves it for the first time. So in this example code, the cache is nothing but an object and state, and then the search function just checks the cache to see if the existing result has been has exist does exist or not. Otherwise, it just awaits the API search, and then it updates the cache with that term as the key, and then it helps us set the result. So the benefit behind caching would be better performance, fewer network requests, and overall it would be a faster experience for users, especially when people tend to repeat the same searches. And now, another important practice when it comes to APIs is throttling requests. So the idea here is to protect your API from overuse by preventing rapid repeated requests. So in this slide, you can see it's a very simple implementation. While the request is in progress, you keep track of it in an is loading state, and then you could disable the button and then re-enable it once the request finishes. And then so this so in so this helps us improve the user experience, and it also protects your app from hitting API limits, because because as you try to work with APIs, you will understand that each API has their own rate limits. So if the user keeps performing the same searches, that is where throttling would help us avoid all that unnecessary traffic to the server. So caching helps when user repeats the same request, and throttling helps when users trigger requests too quickly. And now another and one of the other best practices for with APIs is pagination. So the easiest way to explain pagination is it is like reading a book one chapter at a time, instead of trying to load the whole entire book at once. So the idea here is, instead of fetching up every record up front, the app would request smaller chunks or pages of data as needed. So that would give you faster response times. It would use less memory, and it usually creates a much smoother experience. So in this example on the right, we always keep track of the current page in a state variable, and then inside the use effect, whenever the page number changes, we fetch that specific page from the API and update items with the new data. So the previous and next buttons you see, they simply update the page number, which triggers the use effect to run away. So pagination helps you scale better because you only load the data once, and you only load the data that the user actually needs at the moment. And then so now that we've taken a look at all these concepts in this presentation, let's take a quick a closer look at all the on this guide, which will help you identify the right tools that you would need to improve your React app. So if a component keeps rerunning a slow calculation, that is where you would want to use Memo. If a child component keeps re-rendering for absolutely no reason, that is where you would want to use React.memo, often together with useCallback, just to keep the function properties stable. And then if a user can spam click a button and fire and keep making API unnecessary API calls, that is where throttling helps by disabling the action itself while the request is in progress. And if the app keeps making the same API search over and over, that is where caching is the better fit, because you can store and reuse previous results. And if your initial data load is too large or maybe it's too slow, that is where pagination becomes useful, because you only fetch the chunk of data the user needs right now. So as you can see, each tool solves a different kind of performance problem. The goal is not just to use all of them everywhere, but to identify what kind of bottleneck you are seeing and what kind of tools would be most useful here. So these are just some of the key takeaways from this presentation, and you should always measure and always try to measure the performance before you optimize. It is often said that if it isn't broke, don't fix it. And this is just some of the techniques that we have taken a look at in this presentation. And here we will be, and I think that will be the end of today's presentation. I just wanted to pause right here and see if you guys have any questions so far about the presentation.
Yes. Hi.
Hi.
I have a question. When do rollback? Once I did it and messed up all my code. I just put you have to say like for the last three, at least an example, like three parts of the assignment that not, and then he rolled back everything and I couldn't load it back and it was a mess. It was the last class I took. So what we do in that case, when the rollback do a mess, you don't do the right thing. I mean, I just follow what it says how to do a rollback.
Oh, Okay, so whenever that usually means that your the rollback either moved your project to an earlier commit or an earlier save state. So the newer version is no longer the version that you were looking at. So for the first thing that I would probably check whether the your code is still in the commit history and your local history, or maybe it's in a different branch. So a rollback usually doesn't just remove everything, but it can make it look like the work disappeared if you switch the project back to an older point in time. So in a situation like this, I would recommend to stop making any more changes if you have done so, and then I would recommend taking a look at your current history in Git or your local history itself. Uh, and if you're still not sure about it, we could definitely we could take that you can feel free to book a one-on-one call and we can go through that together. I hope that answers your question.
All right. Thank you. Thank you. Yeah.
Does anybody else have any questions?
Meet, can you explain the caching? What are good scenarios for caching, and how does it work?
Yes, I can definitely be take a closer look at caching. Let me just reshare again. Believe this is where it was. Okay, so caching is typically a great tool to use when the users are likely to make the same request more than once. Uh, Especially with when it comes to looking things up, and then one of the good scenarios for caching is when your app tries to look for something to the API, and when you observe that users uh, try to keep trying to look up the same result, and then go back, and then that is where, if the caching is not set up, that there's a chance that the API may have set some rate limits which could be hit by frequent same requests being made across different users. So this is a real concern when it comes to working on bigger and more complex apps. So the way that caching works is that you would just store the results of a search request in state, usually with the search term as the key, and then when the user searches for it, so the app could first check whether that term already exists in the cache. If it does, you can return that response immediately. If it does not, then you can just fetch from the API, store the result in the cache, and you could save it from for future use. Does that answer your question?
Yeah, do we have like a separate hook for that, or how would we do that? Is it like customized, or do we have like a built-in hook for that? That that's what I was looking for.
Okay, you definitely don't need a separate built-in hook for caching. For to implement a more simple version, you can just use regular React state variables, just like this example you can see in this slide. And if you find yourself repeating that logic in like multiple places in your app, then that would be a great case for a custom hook. You could use something to the effect like use cache search, and then inside the hook you could keep the cache state, the loading state, and the search function together. So as of now, there is not a separate React hook just for caching here. So usually you would start with use state or sometimes even use ref if the list is stationary. And then if you want to use this pattern cleanly, you can try to wrap it up in a custom hook.
Okay, got it. Thank you.
Okay. Are there any other questions?
Kanik, I had a question about that caching that you explained.
Mm-hmm.
Do you use the memo for caching, or the example that you showed, like you were using state, so you would not use memo? I thought that's what is what would be used for caching, but you're using here like a regular state. Uh, is
Right. Uh, right. So in this case, when it comes to caching, you would not usually use memo for that kind of caching. So use memo is mainly for caching just one single value during rendering. It's kind of like a filtered list or if you ever want to add one like maybe 100,000 times. That's just one example of the calculation. But the this example that I've shown here is slightly different because you are not just storing a value, you're storing fetched results, and those results can involve can include objects over time, and then reusing them across. And if you end up reusing them across searches, so that is why you would want to use state variables, which they are usually the better fit. So a simple way to explain would be like use memo, it caches something that is typically calculated by the app, while this cache just stores the data that has come back from the server. So for the search results, I would typically recommend using state variables or sometimes even use ref. But use memo would not usually happen to be the first choice for uh, caching API responses. I hope that answers your question.
Yeah. So basically, what you're saying is anything that requires you to fetch the data from the server, you would put it in the state variable, right? And then only thing that the calculations that are performed, right, which will cause a re-render is what you would have it in the memo. Is that right?
Okay. Yes. That is it, precisely it. That is basically the right idea, which is one small clarification. So data that comes back from the server is usually stored in state variables because there is a chance because it changes over time, and you want the AI to update when that data arrives. And then use memo is usually for derived values, meaning that it is something you calculate from existing state, or maybe it could be from some properties during render as well. So it's not just so it could be also filtered. It could involve filtered lists or sorted lists as well.
Hmm. Okay. Hmm.
Uh, okay. Taji. I think I've seen your raised hands. I'm assuming you have a question.
Yeah, yeah, I have a question. It's more on cats to get a deeper understanding. From what you're saying, it's kind of like reminding me of an app that Nintendo made for its Switch 2. It's like for catching data, you said that it fetches data from a server. Like say for instance, you
Mm-hmm.
make like a video on the Switch 2, you record a video on the Switch 2, and you upload it from the Switch 2. Would that mean that the
Okay.
API that is fetched from is the Switch 2 itself?
So not exactly. So in that particular example, the switch to itself would usually be the client device, not the API. So The API is more likely to be the service or the server that receives the upload, or that receives the upload, stores it, or it returns back to the app. So if you record a video on the Switch 2 and upload it, then I would say that Switch would be the thing sending the request, and then Nintendo's backend or cloud service would usually be the API that handles that request.
Interesting. Because I was listening to you explain it, and it was sounding a lot like what be happening behind the scenes when I be uploading whatever I do on the Switch 2 onto my phone.
Right. Yes. So actually, that is a good real world comparison. But I believe what would probably be happening behind the scenes is your Switch probably records or uploads something, and that request usually goes to Nintendo servers, and then your phone app could request the same data from just Nintendo's backend. And there's a good chance that caching can absolutely be part of that flow if you happen to keep requesting the same video from Nintendo's backend. So if your phone already has fetched your recent uploads list, it might temporarily store that response so that it does not need to request the same list again immediately. So your intuition about that would is absolutely right. The important distinction is just that the device is the client and the backend service or the server is the API that's handling that data. I hope that answers your question.
That actually that actually makes a lot more sense. So the Nintendo server itself that the Switch 2 is uploading itself is the one that's how did you say again?
Uh,
Is
so
sending
so it's actually the client device. Your
client
current Nintendo
device.
Switch is the client device that would be where that would be responsible for either uploading videos, or maybe it could also act as an interface to download any videos that you may have uploaded to your own server. So yes, I believe that in this case, your Switch or the phone app itself could be the client.
So it's all depending on the server and it uploads to the client when it's requested.
Yes. So the
All
server
right.
provides the response and the client is the one requesting it.
Got it. Got it. I just wanted a deeper understanding of catch using what I have as an example.
Yes, that's totally fine. And actually, that's actually a really good example to think through. So caching is just basically temporarily saving data. So you already got back. So you do not have to ask for it again right away.
Okay. Cool.
All right. Does anybody else have any other questions?
Can you tell some scenarios where caching can be used outside the what video example was used?
Okay. So caching can definitely be useful in a lot of places, just outside the video example. So a few common examples involve search autocomplete, or maybe whenever you're trying to browsing through products in catalogs, or when it comes to shopping apps. It can also be used to load weather data for a certain city, and then you could also so for let's try to consider the example of a shopping app. So if a user searches for the same product twice, you can reuse the previous result. And then if they open their profile page more than once in a short time, you can always reuse that fetched user data. So if they move, and then if they move between pages in the catalog itself, that is where you can also cache pages 1 and 2 of that particular catalog instead of fetching it again immediately. And then let's try to consider another scenario where you're trying to look up the weather. in a given city. So if I ask for today's weather in New York, let's say in New York like 10 seconds ago, I would probably I don't need to call the API right again. If I were to check the weather again in the next minute, I can just reuse that response for a short period. So those are some of the examples where caching can be useful.
Thanks for explaining.
All right. Are there any more questions? Right after this, I'll be jumping into the coding just to walk through for to explain the examples that they to help you guys visualize more on the concepts. So I'll just be taking a moment, just taking 1 minute to see if there are any other questions, or else we could just jump in the walkthrough. Okay, if there are no other questions, let's just go ahead and jump into the code walkthrough. For this part, I actually want to focus on what changed up from last week and how those concepts, the concepts that we've seen in the slides, actually show up in the updated app. So let's take a look at it together. Okay, I hope everybody can see my screen. And now let's take a look at our counter component first. This is just example from last week. The in term And then I've just built up on it just to include all the concepts that we've seen in the slides. So let's take a look at our counter component first. So compared to last week, there are just two main updates here. So first, we added use memo to cache the expensive calculation, which would be looking like this. And then we have wrapped the add to method in use callback. So its function reference stays stable between renders. And then the point behind this particular function is that it is deliberately slow, since if you take a closer look at the code, it loops literally through a million times. So without so if I so without use memo, it would run on every render, even run related ones. So with use memo, it would only rerun when the count changes, which is one of the optimizations that we had talked about in the slides. Let's take a closer look at how the app actually looks like, and let's try to explore this. Are we in the right? Okay, this needs to go inside. Okay, for now, I just want you to focus on the these two, the first two results of the console, and the first message right here is that the expensive calculation has started from the counter component, and the second one is just the filtered list calculation. We'll be taking a look at that later, and then so if I click add one, the counter changes, and then so you will see that the computing stats calculation is running again. That is expected because the entire calculation is dependent upon the count variable. So the key thing to watch is what does not happen. So if something unrelated in the apps change, so the use memo should let React use the same cache result instead of recalculating those values again. So the console is basically the proof is sort of like the proof that our optimization is working. And now let's take a look at some other components that involves that is okay. So let's try to take a closer look at so let's take a closer look at our shopping list example. And then in this shopping list example, what the some of the this so compared to last week, the big change here is that we have added a search input at the very top, and the filtering logic is now wrapped in use memo. So the filtered list itself is cached instead of being computed on every single render. So if as you type in this search box, the list filters in real time. So if I type something like P, you should only see the filtering message appear in the console. And then if I keep typing ER, because then it would run again because our search query has changed. And then if I add a new item here, let's say I wanna add some lettuce, then it would probably run again because the list itself has changed too. So, one thing to understand here is that both the search query and working items are dependent upon the initial shopping list. So, React only is able to recompute the filtered list when one of those values actually change. So, if the app re-renders for some unrelated reason, like maybe the dialog state changing somewhere else. The filter does not run again, and React just reuses the same result. So if we try to uh, keep the search here and we just change the dialog, you can see that the list is unaffected. And then you can also notice that if the search box is empty, the code can return the full list instead of just doing unnecessary filtering. So, and this is one of our clearest examples of caching using use memo. Now, keep in mind that now this is for a completely static list, and that is why use memo has been used here. But in cases when it comes to dealing with uh, It is since shopping list is kind of like a static list, so that is why useMemo makes sense here. We already have the data here, and we're just trying to optimize the filtering work. But if this were searching through a remote based database to an API, then we would store the fetched results in state. And if you wanted to reuse the old search, that is where a cache object or a custom hook would make much more sense. So now let's try to take a closer look at the student roster right here. And then you can see that all the results. Uh, so in this student roster, so this is where we can see the a better use of React.memo and the use callback hook come together. So the big change from last week is that now the student card is wrapped in the use callback hook so that the memo so that they remain in memory. And then if you take a closer look at student card, it would always log it would always log something it would always log something like student card that has been rendered. So on the initial page, all the cards render once, so you should see all of them being logged here, all of them being logged here. And so so if I click on any one of those examples, only one of the or one of the cards whose props have changed should re-render. So if I so now that I've clicked on the Ethan, the only card that has been locked is Ethan, because one of the properties like is selected has changed, and the other cards do not log at all, since their properties stayed the same, and the React memo would skip them. So the reason why this would work is that all this helps us provide because the React memo performs shallow comparison. So it checks whether the properties are the same by reference, especially functional props. So if if the function to handle selected student were recreated on every parent render, then React would see the on select as a change prop, and the cards would re-render everywhere. So that is exactly why the parent wraps the handler for selecting students, and that is where we can see this particular function, being passed here. So that is where you can so React Memo helps us skip unnecessary child renders, and then use callback is only helps keep the function property really stable, and together they solve the exact problem that was shown in the presentation, where a child component re-renders for no clear reason. And now let's take a look at something new. So this is an addition to our example from last week. So this component is brand new, and it is our real world example of pagination. It fetches actual data from actual Pokemon data from Poke API, which shows 10 Pokemon at a time, and lets us move forward with it lets us move forward with the backwards and previous button. So a really important point here is that use callback is not just not a performance optimization in this component. it's a requirement. Let's take a closer look at the API itself. So I think this will help you understand more. And now, so if you look at the code here, the key thing is that the fetch Pokemon version is wrapped up in use callback, and this is what helps us keep the function reference stable between renders. So the reason that matters is it's because use effect depends on on use effect is dependent upon on the fetch Pokemon function. So if it were a regular function, React would just recreate it on every render, and then use effect would keep thinking that the dependency changed every time, and that would keep triggering another fetch, which can turn into an infinite loop. So in this component, use callback is not just about making things faster. It's what breaks that cycle by keeping the fetch function stable unless its real dependency changes. And then the flow but becomes much cleaner. The offset changes only when I click next or previous, and then fetch Pokemon updates, and then that is why the use effect runs, and then we can fetch the next page of Pokemon itself. So this component also keeps a track of the Pokemon, then the offset and total count, and then loading, and also it also stores the error if in case there are any issues with the API, which is a really simple real world example of how you can implement pagination in API. So this is how this is how you would typically work with APIs and store the results. And uh, yeah, I think so. What you see on the screen right now is just page 1 of 135, which is showing that our API has fetched about 1350 Pokemon, which makes the pagination part very concrete for this example. If I were to show all 1350 Pokemon on the same page, it just would not look right. And also you can see that the previous button is disabled here since we are already on the first page. And then when I click next, that is where the offset changes, the fetch runs again, and then we load the next batch instead of trying to load all 1350 records at once. So this component brings together all the ideas that we have discussed in the presentation. That involves the state for API data, use effect for fetching, and then use callback to handle dependency stability. And then when the data set evolves, that is where you can also use pagination as well. So, are there any questions about the the code that we've just seen?
Can you explain the use callbacks importance in pagination? Initially, I saw that you've been using use effect, uh, and you told that you want to break the infinite loop just by using the use callback hook.
Right. Yes, definitely. So in pagination, use callback is important because our use effect right here, it depends upon the fetch function. So if our fetch function was written as a regular function inside the component, then React would recreate that function on every single render. Then use effect would see a different function reference every single time, and it would assume that the dependency has changed and keep running it again. So since the effect itself updates state, that can create an infinite loop of fetch, render, fetch loop. So that is why the fetch function had to be wrapped up in use callback, because that function, because it helps us keep that function stable between renders, unless it's real dependency, which would be in this case is the offset that that actually changes. So in this component, use callback is not mainly about making the code faster. It is all about making the use effect dependency behave correctly. So in pagination, use callback stabilizes the fetch function so that use effect only runs once when the page input changes and not on every single render of the page. I hope that makes sense.
Yeah, which piece of code will be used when we call many times for the pagination?
I'm
That
sorry,
should be
could
the.
you repeat that?
Can you go to the callback code piece of code that uses callback?
Yeah. I think this is the code. Is this the code that you're talking about?
Yes, yes. So, on click of which button will that code be called? The callback be called?
Okay. So as of right now, it would so it's not called directly by the next or the previous button. So what those buttons do is just update the page state, and then once I refresh this app, it would already call the first M items from our API list. So the flow is when you click on next or previous,
Mm-hmm.
that would update our offset here, because it is a dependency of our fetching function inside the use callback. So React creates that updated callback, and then use effect sees that the fetch function has changed and runs it. So technically, the button click would trigger that function, and that change is what leads us to the use callback being called again and again.
So, in the use effects dependency, you're using the use callback function. Correct me if I'm wrong.
I'm sorry, could you repeat that again?
In use effects dependency, the that is where the fetch Pokemon is
Yep,
the callback. Is it the callback
exactly.
fetch?
Yes, yes. So the fetch
Hmm.
function is wrapped in the is the function that is returned by the use callback here.
Mm-hmm.
So in this line right here, this line is the key. That means that this effect will run whenever the reference to that callback changes. And because the fetching function itself depends upon the offset on the offset, which so through the use callback function. So changing the offset creates a new reference to fetch more Pokemon, and then use
Mm-hmm.
effect notices that change and runs the fetch itself.
Okay, got it. Thank you.
Are there any more questions? Okay. Uh, if there aren't any more questions, we can go ahead and stop here today. So don't worry about all these examples. They will be made available on GitHub along with the today's recording and the presentation that we've seen in today's session. I just hope that this session gave you about some clarity on the concepts that we've discussed for this week. And with that, I'm just gonna go ahead and wrap up this session today.